another program. Okay, so here we have seen sequences which are ordered list of objects. We have seen that these are range, and these are domain. Okay, domain, the first one is domain, the second one is range. And we have some formulas. We talk about formulas. Here we have domain integer numbers like 1, 2, 3, 4, 5, and we put 1 here and we get 1 over 2 to the power 0 is 1. Okay, then we put 2 instead of n, then we have 1 over 2. We put 3 here and we have 1 over 4. And these are sequences. These are range, by the way. These are range, and these are formulas of these sequences. We have seen how we can find first 5 terms for a sequence. This is a rule formula for a sequence, another sequence. And how we obtain this sequence? We put n equals to 1 first of all and have 0. Then we put n equals to 2 here. Instead of this n we put 2 and we have 1 over 2. Then we put 3, we have 2 over 3. Yes, and we see that as a result it converges to 1. The bigger that n is, the bigger that we have numbers of n, like 200, then we have, for example, 400, 1000, it gets closer to 1. We say this, it converges to 1. Okay, you see that the numbers, this is half, this is more than half. Okay, this is 3 over 4, and this is bigger than this also. It gets bigger, and it gets closer to 1. So we say it converges to 1. And here, again, let us write 5 terms. This is the formula. We have solved these questions before on Wednesday. So here, how we can write the formula? We substitute 1, 2, 3. So we put these numbers, n equals to 1, 2, 3, 4, 5. Let me write them here. So we put n equals to 1, n equals to 1, n equals to 2, n equals to 3, n equals to 4, and we say these values are the domain values. This one is here. Then I'm going to take some more shapes from here. Yes, here, this is 1, this 1, or this 2, 3, 4, 5, 6. These are domain. And 0, minus 1 over 2, 2 over 3, 4 over 5, minus 5 over 6. These are range. Here, what we see that we have minus here, a negative number, then we have a positive number. We have a negative number and we have a positive number. So it doesn't converge to a certain number. It doesn't converge to a certain number. It goes in the negative direction, then it goes in the positive direction. So we say this diverges. Okay? So it doesn't go in one direction. It goes in negative direction, then in positive direction. Yes, here this is a different sequence. It's a sequence where when n equals to 1, here for all values of n, range is 3. This means that whatever the value is n, okay, n can be 1, 2, 3, 4, 5, okay, 100, it's not important. For all values of n, we have range 3. Okay, so here you can see that it's 3 for all values of n. Okay, and thus we say it, okay, it converges to 3. Okay, because it's always 3, it goes to a number. In fact, it stays there, it doesn't go anywhere, but it stays there. And we say this, it converges. Okay. So L is a horizontal asymptote when sequence converges to L. So let us say that we have a sequence where it converges to L here. Let us say that we have a sequence where it converges to L, this L value here in the middle. Okay, so this E is L minus E is the neighborhood here, and here L plus E. So the neighborhood A minus E and the neighborhood L plus E. So if you watch this here, these are sequence, okay, and if they converge to L, the conversion means it gets close to L, or it reaches in the end to L, okay, and these are the neighborhood. Okay, a sequence that diverges, what about a sequence that diverges? We see that it has different directions. It has here both at top, values at top, positive values, okay, and it has negative values. So it doesn't reach to a certain number. Here it has positive values and negative values. Like the example here, it has positive values and negative values. And when it is like that, when the range, okay, is like this, always domain is 1, 2, 3, 4, 5, the integers. Domain is the integers. And when we have a range positive, negative, we say it diverges. Yes, here let us see infinite series. Okay, this is an infinite series. We add these numbers infinite times. It continues like this, it means. Okay, so here again we put n equals to 1, n equals to 2, 4, these values. Here again we put n equals to 1 and we have 1 over 2. We put n equals to 2 and we have 1 over 4. N equals to 3 and we have 1 over 8. N equals to 4 and we have 1 over 16. So again like this, and this continues. So okay, what about this 1? Okay, so this is we don't have a formula, we have a certain number, a 1 here. Here adding infinite times this number 1. So here this when it is infinite, we say that this series is diverges, and here it equals to n. Here, okay, but here in this case the sequence 1 converges. So let us see, just a moment. Okay, let us pass to other presentations to understand this more. This is another presentation, yes, about series and sequences. So, what is the difference between a sequence and a series? Here, sequence is just numbers separated by commas, okay? It's a list. This is really important to understand what is a sequence and what is a series. So here, when we separate numbers by commas, we say it is a sequence. And when we add them, okay, in a list, it's not important. We have a formula, and when we add them, then it is series. Yes. Okay, so which symbols do we use for a sequence and for a series? Here, this brackets represents a sequence, the numbers separated by commas, and this represents a series. Okay, this is a sequence and this is a series. Here, let us say that these are sequence. Why? They are separated by commas. And here, we can take, if we want to find the limit of a sequence, then we take limit as n goes to infinity. Yes, this is a series again. When you have the summation, it's a series. And when you have these brackets, where is it? Yes, this is sequence. So a series. Let us go to a series. Yes, this is a series, and they are in the form like this. So we have a formula for sum of geometric series. Convergent geometric series, the first term over 1 minus r is the formula for that. We saw examples about that. Yes. So there are some definitions like partial sum. Okay, like this. This is a partial sum. Think about an infinite series. Okay, infinite series in this form. Infinite series. I need again to write. Let me open my okay. Yes, I opened it. Okay, here. Yes, here, let us write a series. Okay, so here, let us say it goes to infinity, infinite series. Okay, and it starts from 1 and an. A to the an. Yes. Okay, this is infinite series. And partial sum is just, we can represent it in different ways. We can say it's like here, S, we can give it a value as sum. The first letter of sum is S. We can say Sn. And in fact, it is from 1 to n. The boundaries are from 1 to n. Okay, we have 1 to n here. And this is an. So this is partial sum. Here, this is infinite, and this is partial sum. Oh no. an. Okay. N. And this can also be represented as big S n. Okay, no, this small one. Yes, here. Okay, this is partial sum of the series, and this is infinite series. Okay, so this is a subset of this one. Okay, if we think Venn diagrams, this is a bigger set and this is a subset. So this is a part of this one. Yes, and to find limit, to find sum of a series, infinite series, what we are going to do, we can take limit. So this equals to this here, infinite series. This here means infinite series. In fact, if we don't write anything, it is infinite series. If we write the boundaries, we know the lower and upper boundary. But here it is infinite series. And here we can write limit as n goes to infinity. Okay, limit as n goes to infinity, Sn. Oops. Yes, small n. Okay, so we calculate this one, and we find limit of infinite series or sum of these infinite series. Sum of the infinite series is the limit as n approaches to infinity, this Sn. Yes, here. So here, if an doesn't approach to 0, here when it goes diverges and when it converges, so we don't have much here. I'm going to pass to other subjects. It diverges, when it goes to positive and negative, and it converges when it goes to a certain number. Yes, this is the third one. Yes, again, so this is another presentation about series, and you can see that now we have absolute value of series here, infinite series. So if this series is called absolutely convergent if this is convergent. Okay, so now we are talking about the absolute values here. You know that they can be negative and positive, like the example here. They can be negative and positive, and if we take just a moment, where are they? Yes, they can be negative and positive, like the example here. But if we take the absolute value, they are always positive. So if they are always positive, they converges to a number. Okay. So here, this type of series takes absolute values here. Here you can see that this is another formula, and this is an infinite series. And here we put values when n equals to 1, it is 1. When n equals to 2, it is this value. So we put values and we get this series here. And this is convergent. This is convergent, absolute convergent, because we take absolute value. Now this is divergent here. This is divergent. This one is divergent. Why? Because it goes, it has positive and negative values. Okay, but here this is absolute convergent. So we take absolute values. Okay, so let us see what else. Yes, we have another convergence. We are going to test the convergence of this series. Here, no, we are not going to see this one. Okay, so I can stop here.